So I would like to welcome all the audience. I would like to welcome the panelists. We are here for the panel on space technologies, and the theme is why to spend money on space science. My name is Mohamed-Slim Alouini. I'm professor of electrical engineering at King Abdullah University of Science and Technology. I have the pleasure to have with me 4 panelists. So the panelists today are Professor Nidhal Guessoum from American University of Sharjah, Professor Riadh Abdelfattah from Subcom Tunis, Engineer Rania Toukaberi, she's a space policy expert based in Germany, and Engineer Ahmed El Fadhel, who is aerospace engineer and also a PhD candidate at the University, Catholic University of Leuven in Belgium. So these are our 4 panelists. So let me start with, I think you all see my screen, right?
Yes.
So I will start with a 5-minute quick introduction to the panel, and then I will give the floor to my fellow panelists. Each one will have also a 5-minute statement, and then we'll move to Q&A session to wrap up this panel. So let me start. I mean, obviously, I'm not a science, a space scientist, or I have not been kind of active in the area of space technology in my early days. But I will tell you how I came to this topic over the recent years. So I'll try to tell you why I'm into these days in space. So as you know, I am more of a telecom engineers, and as you know, the wireless telecom in particular go through different generation of systems. So now we are in the early 2020. Everyone is talking about basically like 5G, because 5G start being deployed worldwide. And then actually, as you notice from this graph, it takes about 10 years to develop a new generation of system, another 10 years to kind of deploy it and make it mature. So now actually, while we are deploying 5G, people are talking about what 6G is going to be or what 6G should be. So there is a lot of speculation about 6G, how 6G is going to be pushing the envelope, going for higher data rate, more massive connectivity, lower latency in communications. So there are many perspective and vision paper on this aspect. But there is one other important aspect that we tend to forget, and this aspect is that essentially roughly half of the world population is still either not connected or underconnected. So what I'm projecting here on the screen is the map of the world with the kind of density of base station, or if you will, the level of connectivity. So although we see a very good connectivity in Europe and USA or North America, there is still a lot of holes. There are a lot of countries, a lot of regions in the world that are either not connected or what we call underconnected, which means they have very low speed, maybe voice quality kind of connectivity, but they don't benefit from, high-speed internet connection. So this is known as a digital divide. It's an important problem. Essentially, there is now a big kind of momentum towards trying to bridge the digital divide in the coming years, because we realize that if we are able to kind of bridge the digital divide, we can create multiple opportunities in e-health, in e-education, in e-finance, in smart farming, and so on. And basically, with that, make the world a better place. Now, one of the problems why we don't have good connectivity in many of these countries is that basically it does not make much economical sense to kind of dig, hundreds, if not thousands of kilometers of cables or fiber optics in order to reach very low or sparsely populated region and areas. Which means if you want to reach these remote areas, you need to use aerial or space network. And when we say aerial and space network, we talk about high altitude platform like drones in the stratosphere. There is like a Facebook project known as Aquila, or a Google project called Loon. And what these projects are all about, they are about sending essentially flying base stations that will be interconnected in the sky, maybe 20 kilometers above ground, and they'll be acting as basically super tower in the air, trying to connect people in the ground. So now there is also some interesting momentum towards using a variety of satellite-based solution, like classical geostationary kind of solution. But now people are talking more and more about low Earth orbit constellation. There are many kind of ongoing projects like OneWeb, Starlink, which is sponsored by SpaceX, Telesat Leo, or the Amazon-based Kuiper project. All of these are satellite-based solution going after global connectivities. So there is also within the satellite industry quite a bit of interest to go towards what people call hybrid, very high throughput satellite. These are satellites that can kind of process up to 1 terabit per second. They have like beamforming kind of technology. They may end up having optical laser feeder link for super high speed backhaul to ground. So all of this make telecom engineer like myself getting more and more and try to understand better space technologies, because we need space to be able to connect these remote regions. Now, obviously, when you develop technologies to connect these remote regions, indirectly you're helping yourself by basically connecting areas when you are in emergency situation. So what I'm trying to say, it can happen that you live in an area where you are well connected, but kind of a disaster happens, like either a natural disaster or let's say like a terrorist attacks or something like that, and you lose connectivity. And then essentially you can rely on this space-based solution to create temporary emergency type network. So that's also one kind of motivation behind going towards this aerial and space solution. Let me conclude by saying, although the main motivation is to connect people, actually once you create this, let's say, kind of infrastructure to connect people, automatically you are helping yourself to basically connect all kind of sensor, all kind of devices. And then when you have this kind of IoT connected world, you can kind of pursue many big objectives, like, for example, real-time climate monitoring by collecting data that is going to come from different environments. So connecting the world has also a lot of benefits in terms of connecting devices that are scattered throughout the world, and that will allow you to do better prediction of a variety of kind of environmental-based issues like climate. With that, I would like, as I mentioned to you, give the floor to my colleagues. I gave you my personal kind of story, why I got into space-related research from at least a telecom engineering perspective. My other colleagues may talk about a few other things. So I would like to give now the hand to Professor Nidhal Guessoum from American University of Sharjah, who will tell us his perspective on space technologies and why we should invest in space technologies. Professor Nidhal, the floor is yours.
Thank you very much, Professor Slim. Assalamu alaikum. Good afternoon. Masa al-khair. Ahlan wa sahlan. So I'm going to speak in English, but for those in the chat who are asking about Arabic, we will be more than happy to answer questions in Arabic during the Q&A. And I think my presentation, even though the slides will be in English, will be very clear and simple, and everybody will be able to understand. I come to this topic from a different angle or different side of the equation. I am not a technologist. I am not a person of engineering background. I am an astrophysicist. In about 10 days, 11 days or so, the United Arab Emirates, where I work and live, is going to send a probe to Mars. And so for years now, and more, we have been hearing the question, what's the point? Why are you spending? Sometimes people say, why are you wasting so much money? We don't know what is the total budget of this mission, but it's certainly in the hundreds of millions of dollars. And so people don't understand, why are you doing this? We are not a superpower. We are not United States. We are not China or European Union. Even Europe unites together to send a probe, and even the European probe to Mars which was scheduled to be sent this year, has been postponed 2 years from now because it is difficult and complicated and expensive. So I have to always and very often answer this question: what's the point of not space technology, but space science? And what's the point of space exploration, not even space applications? So allow me to show this presentation. Share screen. Hopefully I will be able to show this application window. Here we go. Here we go. I hope everybody can see this. So are we wasting our money on space or on other things? So that's how I come to this presentation, very simply. So first of all, how much money are we actually spending on or in space? Just so we know what we are talking about, and then can answer the question, is it worth spending or not? What is humanity spending its money on? So total space budget for all humanity is about $50 billion. We need to remember this number. NASA had a budget this year, 2020, of about $22.6 billion for this year. ESA, the European Space Agency, altogether for Europe, $7.5 billion this year. Roscosmos, the Russian space agency, $2.77 billion. And then China, India, Japan, etc. Altogether, if you add it up, it's about $50 billion. So just we have a number to keep in mind and to know what are we talking about as humans. So this is all humanity. So that's an average of $6.50 per year for each human being. It is essentially, we are asking humans, each of us, to contribute $6.50 on average per year on space altogether. When I say space, I mean all of space, including satellites, including ground stations, including space probes sending to the moon or to Mars or to outside of the solar system. Now, let's compare with other spending. So if we look at military spending, for example, total worldwide spending in the military sector, so this is armament and personnel, it is about $1,750 billion in 2019, the US representing 44% of that, and China about 14%. That's 35 times more than the worldwide space budget, what is spent on military worldwide. And this represents per human being every year a little bit more than $225 per person per year. As I said, 35 times what each human being contributes. Now, most people will say, yeah, but it's not my fault. I don't spend on military. That's not me. So why are you asking me to contribute to space? I don't see the benefit of space, and you're comparing with military spending, which I have no power on. So I say, so let's look at other things that humans spend money on. Cigarettes, in the US alone, $70 billion. That's more than all of space, all of humanity. People will say, I don't smoke. Okay. Alcoholic drinks in the US alone, $250 billion per year. Many people will say, I don't drink, so why are you counting that? Don't count it on me. Okay. Then I say, what about cosmetics? Cosmetics in the world, makeup, perfume, etc., $550 billion a year. And people say, yeah, but I don't put makeup. Okay. Then if you don't put makeup, do you use entertainment, any entertainment? TV, cinema, music, newspapers, magazines? Nobody in the world does not use any of the above, and entertainment and media around the world costs about $1,500 billion per year. Okay, so we're wasting, so people will say, okay, so we're wasting a lot of money in other areas, but does that mean we should also waste money in space? You haven't convinced me that spending money in space or on space is important. So at that point, I say the following. I say, if I say two things to you, in the decade following John Kennedy's announcement that the US is going to go to the moon, and again, going to the moon had essentially zero direct benefit or material benefit, the number in the decade that followed, the number of PhD holders in the US tripled in the physical sciences and quadrupled in engineering. So that's an important benefit for the nation just because there is a big project in space like that. Secondly, a survey in 2009 found that 50% of the internationally renowned scientists who published in Nature, the top journal, had been inspired to become scientists by the US moon program. 50%, that's huge. Still, people will say, yeah, but that's not enough, so you are producing scientists, or that's not a direct benefit to me. And then the final truth, I say, to be honest, it is not, I could, of course, give a whole lecture on spin-offs and indirect benefits and satellites, and we can't work and live without satellites nowadays. There's so many applications. But then I say, in the end, to be honest, we humans spend money on space exploration, such as sending a probe to Mars, because we are curious, because we want to know. And curiosity drives progress. And that's my presentation.
Thank you, Dr. Nidhal. I was muted. Thank you, Dr. Nidhal, for the very nice insight about why we should spend on space technologies. Let us now hear from Professor Riadh Abdelfattah from Subcom Tunis, who will tell us his perspective on why we should spend on space and the kind of space technologies he has been kind of involved with. Thank you.
Thank you, Dr. Singh. Are you seeing my presentation? I have already shared it.
Yes, we see it very well. No problem. Go ahead.
Perfect. Then I would like, first of all, to say good afternoon for all the participants, and thank you, Slim, for inviting me to share with you this panel. My, I will say, the relationship with space is through my PhD and my supervising work with many PhD students and master students, and my work was especially dedicated for, I will say, applied environmental issues, such as disaster management, for flood management, for desertification, soil salinity mapping, landslides mapping. And now for my presentation, I choose to give an overview of if space science could address or not socio-economic challenges in developing countries. And particularly, I would like to take the case of Tunisia. Why I have point this goal is because for now, I am member of the National Outer Space Committee in Tunisia, which are working on developing the Tunisian national space strategy. And right now, Tunisia don't have any agency or I will say space agency that could regulate all the laws, regulate all the exchange and of information and all what could be related to space technology. And for that, I will say how could we, in Tunisia and in other developing countries, convince people to adopt and to develop such a space agency? How could space help in our today's problems? And for that, and for beginning, I will start by choosing to illustrate the benefits of space application with a spectacular illustration of the Falcon 9 launchment, the last launchment 2 months ago. And from here, I would like to extract conclusion, because such a successful space mission depends certainly on accuracy and simulation in modeling and flawless computing and fault-tolerant system. So when crewed space vehicle like the Crew Dragon docked with the crewed International Space Station in the last beginning of June, everyone from the ground mission control to the space station crew have counted on the flight computer system and flight software to get the craft to the station and probably for the future also for back to Earth safely. This was thanks to several developments in space technology. The moral of the story here is that we can indeed believe in the potential of space science and technology to change our world. a lot of technology in the service of life and of societal problematic. Fortunately, new technology development for the space science are coupled to current science objectives. Thus, it was thanks to NOAA weather, for example, satellite, that the first launch of SpaceX crewed rocket was cancelled on Wednesday, 27th of May, due to inclement weather, where the launch window coincides with the bad weather moment, and this was thanks to space, of course, weather satellite. Moreover, and throughout the ascent of the capsule, communication with the staff was possible and even flawless with a pretty sweet touch screens in the Crew Dragon, whereas the old space capsule were not only very charged with equipment, but also not all the time connected with the Earth control station. And you know that right now many places and regions in the Earth are not connected, neither with telephony nor with internet. What we can conclude here for this first part is that it is thanks to the human space flight technology development and navigation and positioning application development, Earth observation development, and space weather and satellite communication development that such a success have been a reality. And it was a dream, as since we are a teenager, we are dreaming of the space, and this dream was success. How it would, the question now is how it could appoint space technology and data for benefit to life on Earth, how we can extract and appoint all of these achievements to solve our societal problem on Earth. Of course, this could be correlated with the Sustainable Development Goals launched in 2015 by the United Nations, where the use of and utilization of space have been shown that it contributes positively to a range of policy areas, including climate and weather monitoring. Also, access to health care and education, water security and water management, efficiency in transportation and agriculture, peacekeeping, security, and humanitarian assistance. The list of Earth impacting space application is nearly endless, and many other valuable contributions are currently in development or being researched. Now, can space and technology bring solution to the developing countries' serious challenges in ensuring the adequate provision of basic necessity? And this will be the second part of my presentation, which is space science for socioeconomic challenges. Here I took the example of Tunisia, where we got a lot of problems and disaster, I will say, from flood to security problems, and how it could be solved, or how space science could propose a solution for it. In fact, in country where failure of a harvest may mean the difference between bounty and starvation, which was the case of Tunisia, that fails to store its bumper crop in July 2019. Satellites could help and have helped planners manage scarce resource and optimizing crop by predicting which vegetation to be planted for next year, for example, or to preserve crops from insects. Moreover, as we got by September 2018, a terrible, I will say, flood in the region of Nidhal. Here, satellites and data satellites could be used for doing a lot of work on prediction, also in managing a problem related to the bad urbanization, or also for predicting precipitation, rate of precipitation that could help in managing and planning preventing from such disaster. The third example was about the first phase of the new security barrier that was created between the frontier between Tunisia and Libya. And here, remote sensing teams, research remote sensing teams in Tunisia have worked on getting free satellite data from Sentinel-1 in order to extract the roads, the off-roads, I would say, the off-roads used by a smuggler and used by terrorists in order to make their circulation. This was possible, and data was extracted about the off-roads from there. A good evolution, I will say here, when, as I said, in Tunisia, there will be a launchment of a nanosatellite by the month of November 2020, and this could be an evolution for having such a dynamic in Tunisia in order to participate with industry, with university, in order to develop such technology for example, following and completing what we cannot get from already launched satellite like Sentinel-1 or others. Then space technology also is a vector of economic development by creating employment through providing spin-off technology, which find application in everyday problems. I think that Nidhal have already seen and give some indication about this without giving more details. But here, this, and really we are convinced that it would be a big solution for the big problem. Actually, we are living here, for example, in Tunisia, for unemployed doctors which cannot have work after their PhD. And this could be a good opportunity, because for space, we need different and pluridisciplinarity for mathematics, for physics, for biology, of course, for other applied science such as mechanics and electronics. That's all for me for my presentation. I have made this as an initiation to debate after with all the participants. And thank you.
Okay, thank you very much, Professor Riadh Abdelfattah. So let us now give the floor to Engineer Rania Toukaberi, who is a space policy expert based in Germany, who will tell us a little bit about her perspective on space technology. Go ahead, Rania.
Okay, so I'm going to share my screen. So here I'm going to reshare my screen, but actually the content will be a little bit different because the audience is a little bit different. So, okay, why to spend money on space? So here I mentioned African space strategy, and this is directly going to answer to this question. So I liked a lot the answer that I had from my colleagues. And I also saw some comments that are very interesting that I'm going to just mention a little bit later. So, okay, let's start.
Yeah, Rania, can you get close to the mic, because again we have a problem with the mic. We cannot hear you very well.
Yes, I think you're gonna hear now better. Do you hear me now?
Maybe is maybe slightly better. The voice is always not very clear, but try your best to get close to the mic, please.
Okay, all right. So I'm not gonna go through all this presentation actually, but I'm gonna just try to mention a few points that can be useful for this session, and to answer to this question, why to spend money on space. So I talked like a few minutes ago about the history, how things were happening, what were the problems. I presented like an analysis of why things didn't work and what was the main problem of not being able to spend money on space, and also what are the priorities and what are the methods. So I'm not also gonna repeat again the history of space development in space, because just to resume what is in here, just to say, so our main issue is that we had many countries that didn't know and didn't make the importance, didn't create like an aware of space exploration and space applications in our daily lives. That was the reason why we were stuck in the same level, and even if we were there for more than 40 and 60 years in space. And also the second problem was that we were mainly fragmented, so all the activities were basically local, and there was mainly no regional governance to cover up everything. So basically, the main answer to this question is why we do need to spend money on space is because we have needs. So we cannot spend money on something that we don't need now, especially if our resources are not so much. So when we try to think a little bit about this, of course, I'm very interested in having a scope in Mars and going to the moon and going to faraway galaxies. This is very interesting, and curiosity is extremely needed. But when I try to see what's happening in the Arab world, in the African countries, I see that we have some priorities that we have to show up, to solve with space applications. And among these needs, you can see here, it's simply few points that we know, all of us, and we do need to solve. And if space applications can solve these problems in a fast and efficient way, so we have already problem solved, and we don't need to think twice why we should use space applications. So my colleagues mentioned a lot about the management of the disasters, of the mapping, of management of resources, and I personally participated in many projects for management of resources. For Europe, we can say for Africa, we need it even more. And also for educational side, for satellites. So these are mainly points that we do need to understand that we need, it's mainly a need. So it's something that is crucial and basic for the development of the activities, all fields, in all fields. So, but I would like to say that actually the problem is that this is not enough. So it's not enough to have a need in order to convince people to spend money, to invest in space. So an investor, when they try to think where to put his money and why to put his money, he would try to say basically what is happening around, what is the current situation, and if it will give him and allow him to put money in a secure way. So, and the good news is that when we try to see in the international and a regional level, we will see that there is a big changement. We will see that in the international level, we have like a big space culture going on now. We all followed Elon Musk, what he has done so far. We all followed what everyone, like, for example, now we have the scope that is going to Mars and what is happening around. So this is very good. This is creating the awareness of space. It creates space culture. So when we have this, we have, let's say, we have to follow the global development and we have to take profit from this. So this is very important to see what's happening. And on the market side, we have basically more companies, and then we will have more clients, and then we have more network, bigger network, and then at the end we will have a market. So when an investor sees that we have already a market, he will start thinking about how to put his money in and how to invest in space. As well, on the regional side, it's even better. So, so here, these are for the priorities. On the regional side, it's even better because we do need space in a raw market. We have nothing related to space. Mainly, it's very, very rare to have countries that are focused a lot on space. So when you have a raw market, you are able to, you have a big range of possibilities of clients, let's say, you can work with. We have governments, you have institutions, you have organizations. You can make partnerships with many countries. You can make like a big partnership with international level. So this high demand of space in the regional side, it allows us maybe it allows the investors, it should give the investor the capacity to start investing. And also the other problem that we had before is that we had basically no governance. So now what we are trying to do is we try in Africa at least to make the framework more regulate the framework. So, and we try to have a more structured market. So with having a more structured market, so you can say that now we have one database, we have one institution that is focused on innovation, that has a clear budget, that has a clear network for collaboration, and that is managing everything in a very harmonious way. So again, just to make a resume of what I said, so I tried to show some slides of what I showed like a few minutes ago, just to give you a little bit an overview. So just to say in 3 words, so we have mainly a high demand on space for the needs, for our basic needs. And it's not only for space exploration, it's something that we have to use on a daily basis. The second point is that if you have a very a very clear situation, an economical way and political way. So, and you know that we are talking now about space culture. So there is no issues, there is no threats, just minor of them. And the third thing is that we are now talking about a structured market. So maybe this will bring enthusiasm also to the investors to put money in. So I see, and I do believe, if we are able to communicate these 3 points, and we are able to convince these people to put their money, I guess there is really no issue, and we can even talk about how to create startups and how to partner with ESA, with NASA, with main space agencies, with the African Space Agency, and I do believe we already started. So yeah, so this is mainly what I said here. So I said here that we have mainly the same vision in the Arab and African world. We have similar priorities, similar problems. We are following the same spirit. We have raw markets, and we do need now to exchange experiences and knowledge in order just to kick off this market. Though this is like just an introduction of this session, maybe we can talk about more details later with my colleagues.
Okay, thank you very much, Rania. Let us now kind of wrap up this opening statement by giving the floor to Engineer Ahmed El Fadhel. So Ahmed is an aerospace engineer, and he's actually currently also a PhD candidate at the Université Catholique de Louvain in Belgium. So Ahmed, the floor is yours. Go ahead, please.
شكرا دكتور سليم. قبل كل شيء نحب نشكرك ونشكر كل اللي سهروا على تنظيم يعني الملتقى هذيا، وكذلك نشكر كل الحضور يعني لاهتمامهم بمواضيع من النوع هذيا. وإن شاء الله في نهاية يعني المحادثة هذيا يخرجوا على الأقل 50% من اللي نشوف فيهم حاضرين معنا مقتنعين 100% أنه الفضاء صار ضرورة مش اختيار. فأنا باش نبدأ أول حاجة يعني I will share my screen. Okay, do you see my screen?
Yes, go ahead, Ahmed.
Okay, very good. So thank you very much for this summit organizers for providing us the opportunity to talk about and to debate about this important topic and to answer the question why to spend money on space. So I am Ahmed El Fadhel. I am an aerospace engineer and PhD candidate at the Université Catholique de Louvain here in Belgium. Today I'm going to start by thinking about an answer to this question. So Rania said to spend money, we need to have needs. So that's true. And for me, I will debate more on what are the challenges and what are the problems that we need to solve by using space. So we have problems and challenges. So what are they and why space and how more and why space can be used to solve them. So the first challenge that I will talk about here is that it's very common challenge, which is that in remote areas we have students that walk for miles and for very long distances to reach their schools. So this is an issue because they are actually living and walking all these distances in very harsh environment and very harsh conditions, and this is very difficult for them as kids to live this experience. So actually space, the one category of satellites will help address this challenge, which is the communication satellites. So actually using communication satellites, what we can do for these kids is that we can provide them education at their home, so or in the village where they live, not too far away, and this will be through distance learning and communication satellites. So another challenge that I'm going to talk about here is that sometimes we have a huge quantity of crops. And for example, here what you see in the images, these are actually not sand, but this is actually cereals. So imagine this quantity of cereals exposed like this to weather conditions, to also rain. So it can easily be wasted, and this is really something that cannot be accepted. So now, what is the issue? Actually, when you don't predict that you will have an excess of crops and cereals at the end of the year, so you cannot get prepared for it. So you cannot have the logistics necessary and needed to deal with that excess of crops. So why now satellites can help? So I'm going now to talk about the second category of satellites, which is Earth observation satellites. So it's like you have a camera in space. Okay, so why we can solve this problem using the Earth observation satellites? Because these satellites allow to monitor the crops, so you can follow the evolution and the growth of your crop in your farm during all along the year. So this is very important for farmers, but also for governmental authorities. So in case they will have more crops than expected, we will prepare everything for this. And this is what you see here is in Saudi Arabia. So these are the circles, the famous circles, where the farming circles that are used in general in the desert environments. So we can actually follow this and monitor actually these types of farms. So now another challenge that I'm going to talk about. So it will be illustrated in the story of a young girl that actually she went to school in the morning. She actually was studying at school, and then the governmental authorities in one country they announced that there will be heavy rains. So they asked all the schools to close their doors and to send the students back home. So what happened is that when she was going home, she actually was killed by floods, and this was a tragic event that happened in our Arab region. So actually, why I'm talking about this now? Because the fact that we knew that there will be floods very late, we had to lose the life of this young girl. And this is not accepted. And we can solve actually this using weather satellites. So by relying more on weather satellites that collect data about the weather conditions around the world, we can improve our accuracy of weather forecast, the precision and the accuracy of weather forecast. And in this way, we can actually prepare in advance. And we don't send them to school. We ask them to stay home when there is a high risk for their lives, because their lives matter for us. The last thing that I'll mention here, which is the fourth challenge that we can also solve with satellites, is related to irregular immigration. So you know that hundreds and even thousands of people are lost or are dying every year because actually of the fact that when it happens, when a problem or their vessel actually is damaged, we don't know about that until it is too late. So we cannot save them if we don't know that they are in a trouble, they are in a problem, they are facing a huge challenge and a huge problem, a death problem, a life and death problem. So how now we can actually help using satellites solving this problem. So now we will use navigation satellites, which is the fourth type of satellites that are used for Earth applications. So there is this that you see here. It looks like a phone. Actually, what it does is that when you are in trouble in the middle of the sea, you press a button and it will send the signal to the satellite, and the satellite will relay your signal to the rescue and coordination center. So in this way, the people actually that are responsible on rescuing in damaged vessels will know that you are in trouble. So they will send you helicopters and ships to save your life. And this is very important because, again, people's life matter. So if we want to give importance to their lives, we have to invest in space to save people's lives. So this is very important, I think, for me. And as you understood, investing in space is not an option; it's an obligation, because we are facing a lot of challenges now. So when we have the opportunity to use space technologies, why not using these powerful tools in our hands? Why we are still relying on very traditional techniques? So I hope that this introduction also was very, very clear for you, and I hope that my message is rich. And thank you again, Dr. Slim, for the invitation. I'm very happy to be with you today.
Great. Thanks a lot. I really appreciate all this input from the different panelists. So just to summarize, I think what we learned from today's panel, and before we move to the Q&A session, we can say, I mean, at least what I learned from this panel, that space technologies offer, let's say, a multitude of services ranging from global connectivity and broadcasting, as far as telecom services are concerned, to climate monitoring, to remote sensing for environmental application, all the way to localization, navigation, right? So we discussed, or the panelists gave different perspective on this issue from engineering a kind of application point of view, but also from a maybe kind of a business and policy and regulation perspective. Maybe we can get some questions from the audience. Before I go through the questions, I have a question myself, just out of curiosity, because I'm not a space engineer by training. Let's assume I do undergraduate studies in electrical engineering or in mechanical engineering. How do I specialize and become an aerospace engineer for my graduate studies or my PhD? Can one of the panelists maybe give an answer to this question that might be of interest to some of our audience? Many of them are probably undergraduate students who are doing mechanical engineering or electrical engineering, because I don't think in the Arab world we have many aerospace engineering departments as part of our universities. But we do have, of course, electrical engineering, telecom, mechanical engineering, and maybe some of these students are aspiring to become aerospace engineers. So maybe you can answer this question. I don't know who would like to answer this question. I'm talking here about astronomy or aerospace engineering, like space technology. Anyone who wants to answer this question? Or maybe everyone can give a quick 2-minute answer.
I think, Nidhal, would you like to begin, or I think that everyone
Nidhal, go ahead,
from the
Professor
panel.
Nidhal.
Yeah, okay.
It's an engineering question, so let's hear the engineers.
Okay. I will give the example of the development
I guess
of
coming from physics background, right?
Sorry?
If we are talking about astronomy, I assume that essentially people with physics background can get into astronomy as part of their graduate studies. So we can talk in general, how do we move from an undergraduate studies in physics, in mathematics, in electrical engineering, mechanical engineering, to space technology kind of graduate degrees, master and PhD.
Okay.
Yeah, let's start with Dr. Nidhal.
Okay, so there are two different things here, and I think I try to allude to it in my brief presentation. There's space science, and then there's space technology. Space science itself is divided into two big branches. There's satellite immediate space environment, which is a few hundred to a few thousand kilometers from Earth, and then there is space exploration, which is when you reach the moon and the planets and beyond. Yes. So part of it is space science and part of it is astronomy or astrophysics. All of this comes under physics normally. Physics, astronomy, and there are departments of physics, departments of astronomy in the world, and even in the Arab world, there are a few departments of astronomy. And then you can do specialize in space science or space physics or astrophysics and so on. Now, engineering or space technology, that requires engineering. There are in the Arab world, including at my university, not departments, but at least minors and at least some programs that specialize in aerospace engineering. So that's rocketry, satellite, telecommunications between satellites and ground stations, and so on and so forth. So that's an engineering route. That's why I said, let's hear from the engineers to explain how people can specialize from electrical engineering to aerospace engineering and so forth.
Very good. Let's hear from Professor Abdelfattah before moving to Ahmed and Rania.
Thank you, Professor Slim. What I can add as a complement to what have been said by Professor Nidhal is that the developing country, as not necessarily they have aerospace technology or aerospace science, which needs a lot of money in order to do this, for also capacity building and developing rockets or other. There will be such a thing like hands-on practice for engineering working on all the application fields. If I can take the example of nanosatellite launchment, this could be a very good project of practice for different engineering. Telecommunication engineering, mechanical engineering, communication engineering, electrical engineering for the panel, and this could make people working together. They are not developing courses dedicated for aerospace or for this such application, but they will just use their competences and their knowledge that they have taken within the courses of the engineering they are looking for, in order to apply it in their final year project, for example, or integrated year and their second year of engineering. And this it becomes more and more common now that 3, 4, 5 school engineering are together around a project such a federated project of nanosatellite. It is a successful project that I've seen in France, in Germany, and in many other places in Europe. I think this could be one step in order that our engineering or future engineering in developing country taken and having more competences in this field of aerospace without having necessary the aerospace discipline in our study and in our curriculum masters or PhD.
Okay, thank you very much, Professor Riadh. Rania and Ahmed, can you share with us your experience, how you got into aerospace engineering as a graduate, as a master or PhD student?
I'm gonna just talk about my personal experience as well as what we try to do for this current problem, because this is not problem or this challenge, let's say, for the to bring more people in space industry. To start with my personal experience, so I started as engineer of electronics from INSET in Tunisia, and it was like my first starting point was my graduation project that was on CubeSat. So just to confirm what Mr. Abdelfattah said. So I worked on a CubeSat. I designed the telecommunication card in university in France, actually. So that was the first point where I said, yes, okay, now I just want to focus more on space. Then I did a master on embedded systems for space applications. And I made also master on space development as well for space applications. So it was all focused on this. And I also continued several number of certificates for cryptography. That was with my work, because they decided to form me on this level as well. For the communication, satellites communication, cryptography, and several other certificates, also space policy. So that's my personal experience. So on another side, what we are doing as GSC, UNOSA, and what we try to do is what we just said. We need to form people. We have now engineers in electronics, mechanical, biology. We have even space artists. So we have all kind of people that want to work for space. What we do is that we make like short trainings for them. Either we involve them in projects like CubeSats or constellations, whatever. Or we try to form them in general to teach them what does mean space, what does mean building a spacecraft, what does mean space system, what does mean space regulations, space law, etc. But for the next generations, I guess the space program should be really implemented in the official programs, educational programs. So I think governments should take this in consideration later.
Okay, great. Thanks, Rania. Ahmed, what about you?
شكرا دكتور سليم. هو الحقيقة مجال الفضاء بصفة عامة يجمع العديد من المجالات، فبالتالي لو أنت مهندس في هندسة إلكترونية أو ميكانيكية أو إعلامية أو ثيرمال أو أي نوع من مجالات الهندسة بإمكانك الدخول لمجال الفضاء. فأنا نشوف أسهل طريقة أنك تقدر تدخل بها، وأنا اعتمدتها الحقيقة، أنك تكون في معناتها تعمل مشروع ختم الدراسة متاعك في مجال الفضاء، معناتها حتى ولو جاي من هندسه مثلا ميكانيكيه، تمشي تعمل مشروع ختم الدراسات نتاعك في شركه تشتغل على اقمار صناعيه او مركز بحث علمي في هذا المجال. فانا نشوف هذه الحقيقه اسهل طريقه، ونأكد على انه مهما يكون مجالك ديما فما امكانيه باش تدخل في مجال الفضاء، حتى ولو محامي فما مجال كامل اسمه سبيس لو، يعني واللي هو تقدر كمحامي تتخصص فيه. لو طبيب او في مجال الطب في سبيس ميديسن يمكن تختص فيه. لو تشتغل في مجال الفلاحه في سبيس اجريكلتشر ولا سبيس فارمينج، اللي هي مجال مهم جدا وفي تطور مستمر. فبالتالي مهما كان مجالك بامكانك انك تدخل مجال الفضاء. ونظن كما قلت لكم انه احسن طريقه عن طريق ماستر ثيزس، والا عن طريق طبعا يعني فورماسيون وتريننج وبروجرام اللي هو يكون مختص في المجال هذاك. وحاليا فما في الامارات يعني اعلنت وكاله فضاء الامارات انه باش يقوموا باطلاق ماستر في مجال الفضاء، باش يكون مفتوح لكل الاخوه والاخوات من العرب. نفس الشيء معناتها في تونس عندنا شركه تشتغل على اقمار صناعيه، so you can apply for an internship there. In Algeria also they are developing satellites. In Morocco they are working on data processing, so you can work with them also. So this is there are a lot of options that you can follow, and I wish you all the best of luck.
Okay, thank you very much, Ahmed. Maybe we can take one last question. We have only like a fraction of a minute, or like a little bit more than a minute. Is about space debris. Like it's a question regarding pollution, or kind of maybe I can mention this. Like anyone can tell us about maybe the problem that can come with like this increased kind of activity in space and the so-called space debris problem.
استاذ سليم لو تسمح لي نواصل بما اني كملت نرجع مع الموضوع هذا. هو انا شخصيا نظن انه مشكله السبيس دبريز ونفايات الفضاء جايه من المراحل الاولى نتاع استغلال الفضاء، لانه وقتها كان في حرب بارده وكان في تسابق نحو الفضاء وكان في تعامل غير مسؤول من زوز دول الكبار والدول اللي كانت معهم. ولكن توا كل شركه تبعث اي قمر صناعي ولا غيره في ريجوليشنز صارمه جدا. مش ممكن يحطوا لك القمر الصناعي فوق صاروخ ويبعثوه يرسلوه للفضاء لو ما تحترمش القواعد نتاع سبيس دبريز. فتو المشكل كيفاش احنا معناتها يعني نتخلصوا من النفايات المخلفه من السبعينات والستينات والثمانينات القرن الماضي. فهذه هي المشكله، وفي لحد الان ما فيش طريقه الحقيقه كوست افيشنت ويمكن اعتمادها بطريقه فعاله. ونتمنى انه في مجال بحث كبير، يعني لو في شكون مهتمين بالموضوع هذا يقدروا يختصوا فيه حسب رأيي. شكرا.
شكرا أحمد. One last comment on this issue. Okay, I think we are done. Thank you all for your attention, and thank you for all the panelists for their valuable insight. And inshallah, we'll have an opportunity to have some other panels on this topic as part of maybe future PRIS event.